the topic. That means this week we introduce. That is on Saturday. We introduce the mall that is in the morning, and then we continue the mall all that week. The mall is a very wide topic. It normally entails calculations, and then we'll have also. So we'll get ourselves to practicals now. We were discussing with Madam yesterday, and then we were like, maybe we will be doing what do we call a dry practical, a dry one where we just give values and then we do the calculation, which I think that is what we are going to do. Again, to report back is there's somebody who sent me, Monica, I think it is Monica. She tried some 2 questions. So I am yet to handle to really sit down and help her out, you know. So because she's the one who sent the question, so I thought maybe we just do revision today. And there's something now. This one is the KLB. I want you to see the KLB and the one that you're using. So you will just choose one of the books because you have been using the. Now this one is the third book that we're using this time. So we'll choose which one to use, which one you prefer. There are also summarized notes, which I normally find that maybe the explanation I'll have to explain a lot. So we'll choose one. So in the meantime, let us try now to do these ones. There's something that while I was going through the KLB, I found something that maybe we didn't mention because it was missing. It was missing in the 2 books that we use, which is the long one and the top notch. So it was missing, but I think it should be in this one. So we talked about, we said in the gas laws, we have 3 main laws. We have the Boyle's law, we have the Charles law, we have the Graham's law of diffusion. Now, if you see, there's something that I've left out because it is never stated, but it is now a Boyle's Charles law combined. Yeah, that's why it is called combined gas laws. So, but it is never stated. We never stated, but we have a calculation for it. So I wanted us to do each maybe 2 examples. That is, we do one for Boyle's law, we do another one for the Charles law, 2 examples for Charles law. We do interconversion between the Kelvin and the degree Celsius scale. That is the absolute scale and the degree Celsius scale. We do also 2 examples or 3 because it could be technical. And then we do also 2 for the Graham's law. And then now we call this topic, of course, there's something also I wanted us to do, which is the applications of gas laws. Applications, I think we'd never mentioned that one before. And around 3 or 4. So, and then we now say we have ended this topic. So the next time we're going to discuss this topic, maybe we'll be doing revision for the KCSE, or if somebody brings up a question on it. I hope that is okay. So I don't know who is in now, so that I had seen Maura. I don't know. Maura, is it okay what I just said? Yeah,
Yeah,
because you're the only one in.
that's okay.
Yeah, so so this one is now, I had said I'll source for you the KLB, the EKLB. So I'll send it after we are done with this subtopic so that we can see what we'll do later on. So let us start. So we had started, so we start with Boyle's law. We are just going to do it the same way. Yeah, so we have the Boyle's law, and the Boyle's law, we have its equation. So we can do example 1 for Boyle's law, and we do another example for Charles' law. Now, no, for Boyle's law again. So we'll just choose randomly. For example, let us do question number, do 1 or 2. I want us to look for those things that are a little bit tough. So let us do question number 2. So we solve question number 2. Now, so I have zoomed to the maximum. I zoomed this one to the maximum so that it can be very visible when you are doing this one. Now, there's something that we didn't mention very well when you are dealing with this Boy's law again is the graphs, plotting of the graphs. So the plotting of the graphs still maintains the rules that we mentioned when you are dealing with acids, bases, and salts. So the same thing continues, but it is very good to practice graphs. Once umeshika graph, nobody will beat you there. Ukishajua tu kuichora, which from what I received from the others, kuna watu walinitumia kidogo kidogo, now you are doing a good job. If you do your graphs that way, there's no argument that you score the full marks. So keep it up for those ones who sent. Yeah, I marked those graphs. I think I've not marked for Monica only. For that is the two examples that she sent yesterday. So, but I normally mark and give feedback to everyone. So, so let us just do one. Now, it is very important for you to remember anytime you are given a question, study the question, understand the question, so that it will be easier to handle. I mean, you will now choose the most suitable. You have to choose the most suitable formula to use. So you check what has been given. It is very important to check what has been given so that you don't get lost. Now, the question like this is something that I was interested in because we didn't do it in the other questions. For example, the volume of a given mass of gas at, so they have given us the temperature 1 is there and pressure is 750 millimeter mercury is 456. So I'll just circle those ones that we are going to use. 456 centimeters cube. What will be the volume at? So they've given us 25 degrees Celsius. And now, so when I say study the question and understand, study the question and understand, I want you to see, I want you to check this question, whatever I've circled, what do you see in that question? Let me just ask now because you are the only one, Mauro. Somebody is in and I'm looking them out in the question. So if you are in and I'm
temperature and pressure.
Has been given.
Yes.
What about them?
This volume, Bado. Volume 1.
Yeah. Do you remember the statement of Boy's law?
Yeah.
Can you say Boy's law? And then you see what has been given. That is what Boy's law. Boy's law to tumeshitaje? So that you see why I normally insist on people. I want you to check. You can even check your notes. You can even check where you wrote. Why people should study the question first before even the answer. What is it about that?
The volume of a given mass is inversely proportional to its pressure at a constant temperature.
Yes. So what are you realizing? They're giving us the volume, the temperature, but are we using the temperature? Do we use the temperature? It should be what? Constant. So from here, this one and this one is constant. So the first thing you do now is to write the formula, which is P1 V1. This one is a trick question, eh? Is equal to P2. So Mutu, if somebody ajui what is good, if somebody does not know how to state that law, if somebody does not know how to state the law, most probably they will use the combined gas law. Of course, it is very important to say this. The answer that you will get is the same. Yeah, all the temperature is kept constant. But now, you will have consumed a lot of time for nothing. So you will still get the right answer, but it is a little bit cumbersome to go that way. And most teachers actually might penalize you for doing that, for not understanding the question. So where there is P1, you choose P1. So I'll assume this one is our P1. If we don't even assume we are seeing it there. This one is our V. So this one was the trick question. The answer is already there in the question. And then you have P, P2. So you just replace where there is another one. So this question nasema ililetwa watu wajaribu. You should understand it is only testing how you solve things. Does this student know how to solve things? So ukishaweka, so we have P1. I want you to see. Let me try this one. 750. So I'll leave out the allow me to leave out the units for the sake of time, and so multiply. I'm using the green one because it will spill over. But is it visible to see spill over to the black side? Multiply by 54, 56. I want you to see this question. I must solve this question so that you see we already have the answer. Is equivalent to. So we have pressure 1 and pressure 2. So this one is P1 V1. I must write P1 V1 is equal to P2 V2. That is Boyle's law. So we are solving the Boyle's law. So now we put now 750 again, which is the pressure 2. And then you multiply by V, V2. So because we have an unknown on the second part of the question, or second part of the equation, what we do is we divide now to put the unknown as the subject. So divide by 750 over 750. So these 750 and 750 go. 750 of this side and 750 of this side go. We will find V2 ni ngapi? I don't know if you are seeing that the answer was already there. 4, 5, 6. Now, somebody normally say that this question has a problem. Now, if you get a question like this in the exam, don't say it has a problem because I've given the same pressure. Now, students have been saying it has a problem because they calculate and they get that the volume is equal. That is the volume at the beginning when you keep the pressure at 750, and the pressure, of course, the temperature is kept constant. And then you have 750 on the other side, they will say that the question has a problem. I know I'll tell them, if the question is correct, how it has been tested, it doesn't have an error, that is, or the terms that have been used and is not making sense, you have never seen the terms that have been used, that is when the question has a problem. But if everything that has been used you are aware of, then the question is correct. Because I hope it is okay, so that we do another example. So it is very important to remember how the law is stated. I normally do question 2 and every time because of reminding people that the Boyle's law, or in the Boyle's law, we are keeping the temperature constant. So it is very important for us to remember that. Now let us do. I'm skipping the one that has the graph, but I will share the book after this class. Now you can go and plot the graph later on, and then you see, so that you can answer the questions now after doing the graph. So it becomes very easy. But it is very important for us to know how to draw the graph. Let us do, I don't know if we have we have another question. So says Boyle's law, and the general mathematical expression based on the law. So we are not going to do much on that. I don't even, I've already stated the law. We started with that one. So what we are expected to know is maybe now the mathematical expression, which is P1. That one is actually the mathematical expression. V1 is equal to P2 V2. So ukiambiwa you state the law, you are supposed to state the law. And then you are supposed also to give the mathematical representation of that law. Yeah, it is very important. So we can now go to solving question number B. So we stated the law, we said this law states that the volume of a gas is inversely proportional to the pressure provided the temperature is kept constant. Or at a constant temperature, the volume of a given mass of gas is inversely. Remember, inversely proportional. I must insist on that. When we go to Charles' law, we also see what it is. It entails. So we have a gas occupied. So we have volume 1. Yeah, we have pressure 1. So this one now is V1. And this one is P1. And then we have calculate the new volume if. Now, I like this question. Because the last time we were here, I told you there will be problems if you don't know how to SI units of volume. So we'll talk about that one now. So calculate the new volume if the pressure is caused to change to 76. I don't know. Do you think you can solve this one? So we have P2. So what we are looking for is V2. No, tunatafuta. So do you think you can calculate this one? And then I'll solve the next part.
Yes.
Or I just solve it. You solve it. You'll try.
Yeah.
Please try. Let me just give you 2 minutes. This one is one of the easiest questions. If you have the calculator, it is very easy. So I think we have one answer. So we check. So so it is 56.01. That is what I've been given. So we are going to solve it. Now remember, this question is very particular. It is saying after getting the answer, please express the answer in SI unit. So I didn't want the second part to be answered. So if you leave your answer in centimeters cubed, that is not actually the SI units of volume. So let me solve it, and we talk about that one, and then I'll continue. So we have P1, so it will be 774. So allow me again not to write the units. 774 multiplied by 55 is equivalent to 760 multiplied by V2. Remember, we remember the units. Now, if I don't write because of time, we are moving very fast. Remember, I should have written 774 millimeter mercury, and then you have 55 centimeters, and then the other one is the same one. So I divide here divide by 760. But you can see this green color. Yeah, is it visible? Over 760. Very well, that is. Because I know the blue one is normally visible. The reason I normally write with green or sometimes yellow or orange is because sometimes I write this part. And I normally see these ones are better. So this one now you feed the calculator and you have V2 to be equal to. So let me feed it into mine very quickly. So that but I said you should write at least into some decimal. Like kama iko na decimal make sure umeziweka. 774 multiplied by 55. Is this 55? Yeah, divide by 760. Yeah, so you are right. So the answer is actually 56 point 03. Let me just write it to that. 001, 013. And then remember the units were centimeters cubed. The reason I'm writing now the units here is because now I want us to convert. So this question is saying express your answer is in SI units. Now, do you remember the SI? What do you think would be the SI units of volume? Before even I give you the answer. What is the SI units of volume? So what could be the SI units of volume before I give you? The SI units of volume? What do you think is the SI units of volume? So that we see if we, because now it is very important for you to remember how we normally measure these things. It was mentioned, I think, in Form 1, in other subjects. I know all of you in Form 1, maybe you did physics. I think that is where we normally mention the SI units a lot more than the other subjects. So I don't know. Kuna mtu ako na idea what is the SI units of volume? I'll give you the SI units of other things for the sake of this one this time round. So SI units, for example, temperature. Let me start with the one. I want to start with what we know. So temperature is equal to the SI unit of temperature is Kelvin. We normally use Kelvin temperature. I don't know. The only time we use is in the hospital where we talk about degrees Celsius. So I don't know. I think it is only in Africa where we normally say that is the SI units of where we normally say degrees Celsius. So the SI units of temperature is the SI units of pressure. The SI units of pressure is Pascal. Pascal. That is the SI units of pressure. But most of the time we do not. Most of the time, the pressure because of a lot of units that they say we can also use this one. We also have 1 Newton per meter square, which is also correct. It is we normally also use that one most of the time. Yeah, 1 Newton per meter. Which other one? Which other one? There is another one that I'm leaving out. I'm forgetting, but it is there. Newton, you have Pascal. Not this one. This one actually is only what we normally use in atmospheric pressure. It's normally atmospheric pressure process. Pascal, there is another one that I gave where we have 1 Newton per meter is equal to 1 something. So there's no problem. Now, I'll still give you that one. Volume, the SI units of volume. The SI units of volume is meters cubed. That is the SI units of volume. Now, we normally argue that, volume, liters. So but it is very important for you to know the SI units. So when they tell you to convert it to the SI units, that means we are converting it to meters cube. Now, it is also very important for you to ushike a question because sometimes they will tell you in the question, convert your answer into what? into liters or into milliliters. So today this question is actually guiding us so that we know how to express. So we have this. So we have the answer. So mtu akifika hapa and the question was 3 marks, you score 2 automatically because you have not converted. Now in the conversion you must show. Now we saw it this way. 1 meter cube is actually how we normally do 1 meter cube is one. I want to show you how it is done so that if you get lost anywhere, you can still solve that one. 1 meter is like saying 1 meter cube actually ni kusema 1 meter you multiply by another meter, you multiply by another meter. Now remember, so 1 meter actually is equivalent to 100 centimeters. So you are saying 1 meter cube now. I'm just showing you how to do it. I'm going slowly, but I must write this one. So 1 meter ni 100. So you are saying to get a centimeters cube una multiply by 100. That is kama umesahau centimeters cube multiply not centimeters cube. This one now it is 100 centimeters. So you don't write the centimeters cube. 100 centimeters multiply by 100. In all of them you can do this. Kama umesahau how it was normally represented, unafanya hivi. You convert each centimeter. I want you to see in meters cube. That means to multiply mara tatu. Kama ni meter square, that is for area. That means they multiply twice. Yeah, so it is very important for you to know this. So you find out 1 meter cube is equivalent to, so you count the zeros. I write 1 and then you count the zeros. Suppose it is 1, 2, 3, 4, 5, 6. Yeah, is it 6? Yeah. So unaandika 1 for the first 100, for the second 100, for the third 100. And then now the answer is centimeters cube. You have multiplied centimeters 3 times. That is how it is done. So because you have 1 meter cube is equal to a million. Is it a million? I think this one is a million. It's equal to a million centimeters cube. What about 50? So you put 56, our 56 here now. 0.03. 0.13, yeah? Centimeters cube. And then you cross multiply. So inakuja hivi, then you do that. Iko sawa mpaka pale tumefika. So you find 1 meter cube, and I normally advocate now for people to write I normally advocate for people to write the units so that you don't get confused while you are converting. So 1 meter cube, and then you multiply by 56. 56.01. But this question is normally very good. I love it. And then you put centimeters cube. The reason I'm writing is so that you see what will happen. We cancel out. So that you don't get confused when you're writing your answer. So divide by 1 million. So this one you don't cancel out. Actually, what you normally do if you have something like that, as it moves this way, 1 0 goes. Ikisonga tena moja, another 0 goes. That way. Or you can say now you can count the number of zeros. That means ikishafika hapa you can count and you say it is multiplied by 10 raised to negative. But I will advise that if you are not very sure what you are doing, use the calculator so that you get your answer to be 0 point, then you count the zeros now. 1, 2, 3, 4. So you unaweka sasa hapo 0.000 0, and you count another 0, 5, 6 meters cube. Unless there is a query. Have you understood? So when you are told to express the answer in the SI units, please know the SI units of that particular what? Of that particular variable that you have been given. You should know the SI units. So that is why it is very important for you to know the units that are used in those particular variables. For example, in Mesema temperature, we have 2 units, but the SI units of temperature is not actually degrees Celsius. It is the Kelvin. So that one is very important. Tuko sawa mpaka hapo. I want to go to something else. We are done with the Boyle's law. Actually, I wanted those things that we never talked about the other time. As those questions are the ones that nilikuwa nataka tufanye revision. Sio kitu tunajua already. I didn't want to touch on something that we already know. So I still say that when you're drawing graphs, we still maintain the rules that we spoke about the other time. The rules were you should have the scale of you choose a very good scale. Yes, the scale that you're supposed to choose should be the best. That means it covers 3/4 of the page. So those ones are the rules. You should use a pencil, of course. That one goes without questioning. And then I said you skip 2 boxes on your left for the naming of the y-axis, and then you skip also below for naming of the x-axis. Now Charles' law. So Charles' law, do you have to state it? The volume of a given gas is directly proportional. So nilisema Charles' law is directly proportional. Boyle's law is inversely proportional. That one we did that one, so it is okay. All of those ones we did. Now we even did the graph where we said we have the absolute 0. Now, so when we are converting now to convert temperature in degrees Celsius to Kelvin, I want us we that one is very important because it is something that will be there. So to convert degrees Celsius to Kelvin, we add 273, which is very important. For example, convert 204, you're adding 273. That one is easy. My problem normally comes to this one, which I normally find it very confusing, especially to the students. So to convert the temperature in Kelvin scale to degrees Celsius, you minus 273. Now, when I talk about minus, when we talk about adding, there is no problem. Maneno addition, haina issue. Because if you add either way from any direction, you still get the same answer. Whether you say whether you start with 273, whether you start with 273, it is okay. That means if you say 273 plus 204, that one is okay. Now, the problem comes to where now we are saying we are minusing or we are subtracting, depending on how you are taught. So when you are talking about subtracting, it is very specific. It is the temperature that has been given minus 273. If you say now 273 minus that temperature, it will be wrong. So it is very essential that you take care of that one. For example, let us do one example and then we go to conversion, interconversion. Na nimesema I'm still insisting that the absolute scale is there's somebody who is unmute. I don't know. I think you should check if you have muted yourself so that you don't have that interference. So when you are converting, I'm saying the absolute scale is actually the SI units of temperature, which is, so convert the following temperatures to the absolute scale. Yeah. So the absolute scale is actually the correct one. Is the SI units. Let me not say the correct, because also degrees Celsius is correct, but the ones that we use in calculation is the absolute. Okay, so convert the following. So we only add, so for example, it is T plus 273. So you're adding that one. So I think that one we are okay. Yes? Yes. So the temperature of the Kelvin scale is denoted by T, while the Celsius scale is denoted by a small t. That one is something that we normally talk about, but it is normally seen, but it is never mentioned. I don't think teachers normally mention this. I don't even think I mentioned the other time. So the capital T is normally, I'm saying the capital T is I can say it is the principal that place. So that means it is the scale that we're using. I think also this one normally guides students to know which one is the SI unit. We continue, there is no problem. So let us do an example. So conversion, when we convert, we are saying it is T minus 273. Not the other way around. Not 273 minus T. So that one is very important. Don't forget that one. Now, let us go now to an example. So we have a gas occupies. Remember, I have to write before when I do. So we have stated Charles law. We have said it is directly proportional. So we do V1 over T1 is equal to V2 over T2 over T2. The temperature, this T, it is capital T. We have not written the small t this way. And the small t tumesema near degrees. Let me just explain that one. Degrees Celsius. The capital T near Kelvin. So that means because by default it is a capital T. So the temperature that you are using here is Kelvin. I'll repeat that one. The small t represents temperature in degrees Celsius. The capital T represents temperature in Kelvin. So from the formula, we didn't use a small t, we used a capital T. So by default, the temperature should be in what? Kelvin. Very important. Now, a gas occupies 450 centimeters cube at 27 degrees Celsius. What volume would the gas occupy at 177 degrees if the pressure remains constant? Now, don't forget how we stay that low. Don't forget how we stay that low. So the pressure is constant. So the pressure is constant. So we just have to identify. So this one is volume 1. This one is temperature 1. This one is temperature 2. So we are looking for this volume. Now V2 ni ngapi? Yeah. Now there's something that we are supposed to do also. Don't forget that one. So let me just do this line for the sake so that you don't get confused. So where there is V, I replace with. So we have 450 over of course it is centimeters cube over the T1. So T1 is 27. I'll just do the interconversion there, those of time. So acha nifanyie interconversion there, but we already know how to convert. So you just have to convert it. If you are very sure, you will not forget how it is done. You can convert it in the question directly. Yeah. So it is 27 plus 270, 273, and then I close the bracket. Kelvin is equivalent to the volume 2, which we are looking for, over 177 plus 273. I cross the bracket again and it is in Kelvin. And then I do this, cross multiply this one by this one and this one by this one. So 23, is it 27 plus that one? I don't know. Is it 300? I think it is 300. So you have 450. I think you had converted the other one. What is the conversion of this one? And of course it is in centimeters cube. Is equivalent to. So in this one, remember, the pressure is kept constant. So some teachers can be tricky and they'll say a gas occupies 450 at 27 degrees Celsius and a pressure of 760. What will be the volume of the gas will occupy at 177 degrees Celsius and 760? So the pressure has been kept constant by the values. So haijamentioniwa that it has been kept constant, lakini imefanya nini? Keep constant. So you multiply by, is it 300? This one is 300. No. 450 multiplied by, this one is around how many? I don't know. 177 plus 273. It is a value that is easy to do because it is as 3. So we have 50. Is it 50 something? 450? It is around 450 again.
450, sir.
Yes, 450. Kelvin, I'm writing the scale, the units of the variables is equivalent to V2, and then you multiply by 300 V2. Alafu you divide now by the one that, are you seeing how it is done? So I'm saying it is not a must that you show if you are in. Now I'm saying the reason nimefanya hivi is for those students when wameshikwa na time, the remaining time in the exam, maybe ulikaa kwa graph sana ukichora graph, or you are slow when you are doing the exam and it is only 2 hours na imekushika, so you don't have to convert uko kando alafu paste. You can convert it in the answer directly while you are doing now the question. So but then this one is over 300 also. So that one is, so you'll get now the V2. So this one by this 0 and this 0 goes, this 0 goes, I think 45 by 3 is 15. So 15 all the way 45. And remember the Kelvin has gone, huh? So EK and this K has gone. So the answer now is in centimeters cube. Remember that I'm not saying this one. If the question has not directed you to convert to SI or to any other unit, please do not. I beg you. If the question is not insisting or is not asking you to convert to other scale, do not try to convert. You are wasting your time. The answer actually is in centimeters cube. So whatever you do, in fact, some students normally tend to want to convert and then they wanapata wame wrong sasa in the conversion. So wamepotea conversion and then you lose a mark for. So what is the answer? I don't know. This one should be around how much now? So I'm saying tafadhali sorry?
Is it 45 times 15?
No, times, no, it should not be 15. I'm only 15. Yeah, I think it is 15. Yeah, it is 15. Because
Then
it is divided.
Okay.
The
Then the answer is 675.
Yes. So the answer is 675. So nasema ukishapata answer hivi, please do not convert it unless you see ile ingine sasa our answer was not correct to be 56 or something centimeters cube because they were saying convert your answer to us or express the answer in SI units. If this one hawajasema, don't waste time. Let's continue very quickly. That's why I was saying the morning, I don't know, I normally find that 1 hour is very short, especially to start a new topic. But to continue a topic, it can work. But to start a new topic, I don't know. I normally find it that it is very short. That is why I decided, and I found also that kuna vitu sikuwa nimesema in this one. That is what I wanted to. So you get your answer. I hope you have understood that one. I'll still share this. I'll still share this book. Na nilisema again the last time we met, which was on Monday. There is no problem if you don't have the other book and you have the KLB. The KLB alone, that is book 1, book 2, book 3, inatosha upate A. You don't even have to get out of and look for other books. This book, the KLB, is what we use to set exam. That is number 1. And they have very good questions. So if you do the others, then it is good. So we have conversion. I'm not converting again. We have said we are adding. So for example, this one here. For example, let us just do what is the temperature on the Kelvin scale of each of the following 100 degrees. What do you think could be the answer? Now you give me for that 100. I'll give for negative 100. So what is the answer if you're converting to the Kelvin scale or to the absolute scale? If you see wakisema convert to the absolute scale, msiko worried. You already have the answer of absolute scale, which is the Kelvin scale. So what do you think is the answer for one? Only for 100. When you convert it to 373. So automatically this becomes 273 or 173. 173 because you are saying it is negative 100 plus 273 or 273 plus minus 100. So inakuwa 173 hivyo hivyo. But you add for addition, nasema ya addition haina effect juu whether you add it from the left or from the right, you still get the right answer. Yeah, you get the correct answer. But now yenye iko na shida ni ya sasa. So it is how you get this one. Let me just write this one and then I go to something I wanted us to touch on today. So you have T, which is now in degrees Celsius. So I normally write degrees Celsius is equivalent to T minus 273. Or I told the students so that they don't forget, it is the Kelvin that have been given minus 273. So this one is, so degrees Celsius tumesema it is the small t. So you can do that one. Or other teachers will teach you differently. Yes. Somebody saying something?
30 degrees Celsius, the first one.
Yeah, this one is 30. So this one, I'm interested in knowing for 0K actually, which is absolute zero. Again,
Is it?
You mentioned it.
So the last one is 0.
No, I'm saying I'm interested in knowing the answer to that one.
But I think it is 273.
Negative or positive?
Positive.
Because that one now is the important part.
It is negative. It is negative. Yes. Negative 270.
So, yes. So you are supposed to be very keen. In fact, if you guess in the exam, most probably you get it wrong. But if you calculate it physically using a calculator, you'll be okay. Yeah. So this one is what you call the absolute zero. Absolute zero is normally negative 273 degrees Celsius. So those ones. So I didn't want to. So I hope that one is okay. So do we have to do another example for this one? I wanted to do something, which was the application of the gas laws. So the combined gas laws, again, we have those ones, which is normally called the ideal gas equations. We have the standard condition. Yeah, there was a time, I think when we were talking about the standard conditions, there was a problem in the other books. That is why I was saying we have in the KLB, we show the KLB, it will be good. Now this one is the KLB. I'm going to share this book immediately we are done with this class so that you can do other things. Yeah? You can do more practice. Now, if you do the revision exercises of KLB, that is from book 1 to book 4, now uzishike, I'm very sure you will not score less than B. 100% sure. But there is no even negotiating of that. So we have the two standard conditions where you are doing that one. Remember, let me just give you the combined gas laws, so or the ideal gas equation. So it's normally P1, V1. So we said we are combining the Bose law and the Charles law over T1 is equal to P2 V2 over T2. So the combined gas laws is this one. Now the ideal gas equations, we have two conditions now that normally is used in the ideal gas equation. Now the standard conditions is what we call the STP. I think Monica, you are really insisted on that now. Is STP, which is the standard temperature and pressure, and the conditions are now 273 Kelvin. You can convert it, then you see. You can convert the Kelvin to degrees Celsius. That is, I think the previous one we did with degrees Celsius, but we converted it again. So you can convert. So to Kelvin, you minus 273. So you find this one is 0. I think that's 0 degrees Celsius. And then the pressure remains that one, which is, yes, I was This one is the one that I forgot. The units of pressure. Kuna pale tulikuwa tuandike ingine. So we had talked about the Pascal, the 1 Newton per meter square, and then the 1 atmosphere, which we said 1 Newton per meter square is equal to 1 atmosphere. Do you sense? Yeah, I had forgotten the atmosphere. Now, the other condition is RTP, which is the room temperature and pressure, and zilisema ni 298. If you convert to degrees Celsius, utapata we are saying 25. Unakumbuka tulisema 25 degrees Celsius. And now
Yeah.
this one remains. Yes. So hapo sasa imekuwa heri. So if I share, yeah, imekuwa better. So the standard conditions, I wanted people also to see the standard conditions. And then something also that I was interested in people knowing. So we'll do, I think we'll do one calculation. If time allows us, we'll do one calculation for standard conditions. But the good thing about this one is if you know how to convert to Kelvin scale, and you interpret the question correctly, you interpret to swali correctly, you solve it. You will see. We'll do one example for this one. We'll do one example for, let us, I know, so you can do one example for this one. So we have, let us, so the pressure remains constant. It is very important for us to know. So wakikupea swali, for example, I want to do one. I will do question number 2, and we say a given. So question number 2 is saying a given mass of gas occupies 20 centimeters cube at 25 degrees Celsius and 670 millimeter mercury pressure. Find out the volume it will occupy at. I want to change this one B to which condition? You have the conditions. Which condition ilikuwa na 0 degrees na 760? So that which condition ilikuwa na 0 or 273 Kelvin na 760? Is it STP? So the question of this one can be RTP. Is it RTP or STP? Can I go back? You say room temperature is 0 degrees.
Oh,
Yes. So this question can be calculate the volume at
STP.
Yes, STP. So zinakujanga hivyo. So ukiona calculate the volume at STP, this one is actually the values of STP. So another question is calculate the volume, find the volume at, somebody will give you RTP. Nitakupea tu RTP without the values. So this one I'm changing because you already have the values. Yeah. So calculate the volume at STP. So I think there is no problem about this one. I just wanted to tell you what it is. So STP, ukiona STP, you know that you don't cram these things. Actually, it is a very simple thing to kushika. The pressure remains constant in both RTP and STP. The only thing that is changing is the temperature. Where you are getting 0 for STP and 25 for RTP, which is the room temperature. So it is very important. So let us just touch on this one. You see, so we have, you just have to identify. So you see it is P1 V1 over T1. Yeah. So I think when I write it, it becomes better. So upper, that is the equation. Ukiandika, by the way. Now, if you interpret the question correctly, lakini time imekupata. Now umesema collect the papers, because I know they are very strict in your examination location. Sio kama ya shule. I think students are given leniency kidogo. Wanaweza ambiwa, I don't know if you are given, I don't know, I think somebody can tell us, how is it when you are doing your exam? Do they say you have 30 minutes, you have 10? Ikiisha 0, do they add you some time if you are still writing?
no.
Yes. So in high school, actually, the students now, they are lenient to the students more. I don't know if it is, I can say they are student-centered more. So for you, ukishikwa na umeelewa question, lakini umekataa usolve, write the question, write the formula, you score a mark. Yani wakitaka kukunyang'anya, waambie tu hata nimalize the formula itself, hata formula peke yake. Now, the problem with those centers where you're doing exam, I think it is because the people who are employed are paid using time. So like chemistry, they are paid in 2 hours. So 2 hours ikiisha, they want to go. So they don't care. But now those ones who are wanasimamia watoto ni walimu. So watasema wacha wamalize tu, give them. So the school now is not really controlled like the private centers. Now, so you write the formula and then you choose P1, you have V1, you have T1, which was you must convert it to Kelvin scale so that it becomes very easy. You convert iko sawa. Then you have V2, T2 and V2. I don't know. The pressure was kept constant. No, pressure we have. So we have P2. Yeah, they didn't mention it because it was in the question. Ilikuwa kwa swali. So juu ilikuwa kwa swali, we might not mention it. And then the temperature was also in the question. So it has not been mentioned, but it is there. T1, and then we have P2, 7. Now it was in the question, which was now STP. And then now you just place it. Ukipata, you get the answer. Now I'm still insisting that if they don't tell you to convert, don't convert. That is bado na insist you. Aki usiconvert kama hawajakuambia uconvert. I think when I do it in, I don't know, Kiswahili, because we are Kiswahili speaking nation, inatokea vizuri. Kama haijasemekana uconvert to degree Celsius, wachana kwa Kelvin. The answer. Kama hawajasema uconvert to SI units of volume, don't touch. Wachia hapo kwa centimeters cube. In fact, you're wasting time. Again, I'm saying you're wasting time by converting. I will only mark up to where you are correct, which is 16. Whatever you do after that, I don't care. That is for KCSE. But if you answer wrongly in the conversion, you risk being penalized. That is 1 mark for having converted wrongly. So that means you don't know what you're doing. So now, something that I wanted us to touch on, which we didn't touch on the other time again,
Teacher,
was this one. Yes?
I have a question kidogo. I don't know, is
Please
it
ask,
clear?
please ask, please ask. I'll clarify.
So kwa hivyo hapo wakisema okay, given pressure we'll have to use that pressure, but if not given, alafu wakisema at RTP sasa ndio tutatumia 25.
RTP ni room temperature, which is 25 degrees. Na pressure ni 760. Wakisema STP inaenda the other one. It is okay now.
Yeah.
Is it okay?
Sasa.
Yeah. Wasipokupea lakini wakisema STP, sasa tuko na values ya STP, standard temperature and pressure, which is 0 and 760. At room temperature we have 25 and 760. Nimesema pressure haibadiliki. What changes is the temperature. Standard 0, which is 273 Kelvin. Room temperature is 298, which is 25 degrees Celsius. It is a standard value. From the word standard, STP, standard conditions. Yeah. So applications. Now this one is what I wanted to end with today, because even time is, I'm only used 2 minutes, which I hope it is okay. So application of gas flows, we had not mentioned this one, and I really felt that it would be very sad if it is tested na to mention. So number 1, but I'll share the book after this. Please do the other. I gave out some questions in the top notch. Top notch is very good with questions, but it is not very good with reading. If you have not been well conversant with that topic or that subtopic, itakupea issue. So we have now, of course, applications. We are talking about the effects of pressure, temperature, and volume. Yeah, those ones. So number 1 is inflating tires, balloons, depending on the prevailing conditions. That is why watu wakichezanga, I normally use volleyball most of the time, because I think I don't know, I don't like volleyball myself. Normally think it is a very rough game since mtu anataka kugongea mpira. Yeah, I don't like people who do that. Yeah? So inflating tires, balloon. So utapatanga watu walikuwa wanacheza asubuhi na mpira, ikifika saa 8 They say the ball is wanataka to reduce the pressure. Yeah, so it is normally used in inflating tires, balloons, and the rest, and balls. Yeah, depending on the conditions that are there. Now, it is also normally used in designing the aerosol guns, the tear gas canisters. Now, tear gas canisters are normally thrown, and then now the pressure inside is too high than outside, so itatoka. So designing those ones, aerosol guns are normally those ones that are used to spray. Those ones that are used for painting houses. Kuna ama ya kupaint magari. Let me say it is better when you say ya kupaint magari, it is aerosol guns. Ile ya Doom, is it Doom? Kuna hiyo yenye wanaleta ya Doom insecticides ya nyumbani. They normally designed it using that one. And therefore, kuna pia regulation of pressure in aircrafts for comfortable flight environment at IL. That is why when you're in an aeroplane, you don't even realize that you're in an aeroplane, actually. So those ones are some of the applications. So I don't want to use a lot of your time. Let me just wish you the best. A very good week, a very good morning. Those are the things that. So I don't think we touched on the Graham's law, but Graham's law is just the immediate, predecessor that we discussed. We just did it the other day. So I thought tunapaswa kukumbushana hizi, but the applications we had not mentioned, and then maybe the standard conditions that was bringing some issues. Unless there is a query, unless there is a very burning question. Monica, I have your 2 questions. I have not yet analyzed, but I'll reply you to your text after.
Yeah,
And
I did them from nilifanya kutoka
yeah.
Med Family.
Yeah, made familiar. Yeah, that is made familiar. So I'll still give you feedback. I think I'll give you feedback before the end of before midday. You still have my feedback. So unless there is a query, I want to ask to end there. If you have a question on gas laws, you can still pass it during the next, even when you are in class in another topic. We'll still discuss it as point of revision. Unless there is a question, I wish you a very nice day, and we end the class there. Thank you very much for attending.
Nice day too.